going to be working with solving systems of linear equations using a table. Tables are not always practical, but we're going to go ahead and just learn how to understand how to read that table. We'll also learn how to go through and fill out the table. Ultimately, using a table is sometimes time consuming, so we will be learning some other methods of solving systems of linear equation, but we'll start out with this method. And my main purpose for having us go through this method is to practice the concept of substitution in the equations, as well as learning how to read once we have the table filled out to find our solution to our systems of linear equation. So when we work with systems of linear equation, we have to understand that it's a set of working with at least two equations and then finding where those equations have the same answers for our y's. So our solution to our equation is going to be a set of coordinates. As we work through these, we're going to start with substitution. So when we substitute in, our first equation here is y equals x minus 1. And I've already chosen for right now x's that we can use. So if we go through and we substitute in a 0 where we have x, and I'm going to write this a little bit bigger up here. I'm going to put a parenthesis where my x is and minus 1. If we substitute in a 0 to begin with, because we said we wanted 0 to start out with, 0 minus 1 would give us negative 1. Okay, now we're going to go ahead and substitute in our next x, which we chose to do 1 next. Okay, so 1 minus 1 would give us 0. Now we'll go ahead and put a 2 in there. 2 minus 1 would give us 1. And you can see the pattern once you start in through these equations. You can see a pattern that's happening in our table. So you can either choose now to kind of continue the pattern, or you can still substitute. So 3 minus 1 would give us 2. And you can see the pattern here where it was continued to go up by 1. Okay, so now we're going to go ahead and do our second equation. So in our second equation, we had y equals negative x plus 3. So I'm going to write that up here, y equals negative substitution plus 3. And this we worked on back in previous lessons where we worked the substitution model. So we're going to just continue that. It's just that now we're working with two equations instead of one. So our first number is we're going to go ahead and substitute in our 0 first. Okay, so here a negative 0 is still 0, plus 3 is 3. Now we'll substitute in our 1. So negative 1 plus 3 would give us a positive 2. And if you're not comfortable with integers, then you need to pull your calculator out and work through that. My goal and my hope is that you're able to do that, but I don't want that to be what slows you down from being successful. Okay, now I'll plug in a 2. Negative 2 plus 3 would give me a positive 1. And lastly, hopefully, would be our next one, which would be a 3. Negative 3 plus 3 is 0. Okay, so now we're going to learn how to read this table and understand how to find our solution. Our solution, when we do this, is we need to find where we have in our y categories, which are our two red things that I have written out here. We need to find where they have the exact same y. So as I look through these, not the same, not the same. Here we have them the same. Okay, so when we learn to read this table, our coordinates are going to be that set of numbers there, which we found out obviously that the x was our 2. So remember, it's always x then y, just like the alphabet. And our y then, well, in both of these spots we had a 1. So our y would be 1. So our solution to our systems of equation is going to be the coordinates of 2, 1. That's where if we were to graph these lines, we could see them intersect. It's kind of like our breaking point like we had when we just went through and did the activity for this lesson. Okay, so let's try another one. Okay, so here's our next one. The nice thing is the first equation is going to be pretty easy. Our first equation is y equals x. Okay, so if I substitute in our x, well, we put in x, it's a 0. So in other words, these are all going to be the same as x. Just as basic as that. Okay, so now we're going to do our second equation. So our second equation is y equals 2x plus 1. So y equals 2 times x plus 1. So our first x that we're going to put in there is 0. 2 times 0 is 0, plus 1 is 1. Okay, so now we'll go ahead and put our 1 in there. 2 times 1 is 2, plus 1 is 3. All right. Now we'll go ahead and put our 2 in there. 2 times 2 is 4, plus 1 is 5. And put our 3 in there. 2 times 3 is 6, plus 1 is 7. So as we look at our table, we're going to look to see, do we have anything in our y's? Not the same, not the same, not the same, not the same. Uh-oh. This is the downfall of using a table, is sometimes with the first few that we pick, we don't see our solution. So we're going to have to kind of look at what we currently have. So if we look at our first set of numbers here, they're going up by just 1. They're increasing by 1. If we look at our second set of numbers here, they're continuing to go up by 2. Well, if we continue our pattern moving forward with 4, 5, 6, 7, we're just going to see the numbers get further and further apart. So let's go ahead and try maybe a smaller number. Let's try -1 in there. So if we substitute in -1 into our equation, because I'm noticing that these just continue to get further and further apart. Like here, if I look at my x, y, they're 2 apart. Here, they're 3 apart. Here, they're 4 apart. They're going to continue to get further apart. So we're going to try a smaller number. Let's substitute in -1. So 2 times -1 is going to give me -2, plus 1 is -1. And then if I did my first equation, y equals x, well, we said that x was -1. There's our solution right there. Okay, so that's the downfall of using a table, is sometimes in our table, if we pick 4 numbers, the 4 numbers we pick might not work, and we might have to continue using other numbers. So as we look at this table, we see here's where our y's are the same. So our y was -1. Our x, on the other hand, was also -1. Okay, so this would be our solution to our system of equations, -1, -1. So on a graph, that's where our 2 lines would intersect. Okay, so I'm going to have you guys try one on your own. Okay, so kind of a complex equation. What I would highly recommend is writing out your equation and substituting in. So here's the first one. Y equals -5x plus 14. So -5 times your x plus 14. Okay, and then your other equation is y equals x minus 10. So if I write it really big, x minus 10. Okay, so go ahead and pause your video and work your way through this table. And yes, of course, you can use your calculator if you'd like to. Pause your video now and work through this table. Okay, so in this system of equations, once again, we're noticing when we look at the table, as I went through and worked through them, I got each of my y's. I'm not seeing a match in my set of y's, not the same. They're the same digit, but one's positive, one's negative, still not the same, not the same, not the same. So once again, I'm going to have to continue. So if I'm looking at my patterns, I'm seeing it goes down by 5, minus 5, minus 5. So -1 minus 5 would give me a -6. And this would be my fourth number. Let's see if we get that same. So down by 1 will really increase by 1. Increase by 1, increase by 1. So 7, -6. There's our solution. So you should have gotten 4 for your x and -6 for your y. Okay, so once again, like I said, there's downfalls to using the table. My main intent is for you to understand how to read that table in case you were to come across questions where maybe they're giving you the table filled out and you're having to go through and find the solution from the table. We will continue on now. I'm not going to assess you on this, but we're going to go ahead and continue on with working graphs in our next part of this lesson. So good luck with this one. I know at times it can be frustrating, but once again, remember you're looking for where you have the y's that are the same.